Hello, this is Logan Ike in Group 7. I have with me Ian and Logan Roberts. Today we're going to do the group project called Monster Truck Maneuver. Our goals for this class is to find a maneuver. Today we're going to do a ramp through a hoop into another ramp. We're going to find and predict the maximum linear and angular acceleration of the RC car. And then we're going to take an accelerometer, which being my phone, into the RC car and find the maximum linear acceleration using graphs and data.
For the setup, we went ahead and grabbed a bunch of materials out of the lab and just put together two ramps. First ramp being a 35-degree angle that we measured on an app on our phone. And then we grabbed one of the old projects to make our loop and then made a random ramp at the end for the angle that really didn't matter as much. We got inspiration from watching a couple YouTube videos of monster trucks doing really big jumps. Our prediction for the maximum linear acceleration was thought to be in the z-axis when the RC comes out of free fall onto the ramp. Our predicted angular acceleration would also be in the angular z-axis, as the force from landing on one wheel could create a massive acceleration.
After setting up the ramps, we tested multiple times with the car to make sure we were confident in completing the jump and got distances down for where we should place the landing and did a consistent run up of 40 feet to the jump. And after we were confident and had completed it multiple times, then we set up to record by standing right next to where the loop would be in the jump. And it took a few tries once we started recording just due to messing up, but eventually we got it pretty quick. And overall, it went pretty smoothly. It was fun to deal with the car and have to keep the batteries charged up and get to driving around and have fun with it. And
for this lab, we do two tests, but for right now, we're going to go into the first test. For the first test, we have a graph of data from X, Y, and Z, and then from all the accelerations here. And looking at the data we have, we can see that the maximum linear acceleration is on the y-axis, being negative 73.16 meters per second squared. For the angular acceleration, we got negative 44.71 meters per second squared in the y direction, or y-axis. And then looking at the graph here, we can see it's really noisy, but you can definitely see when the jump happened and when it landed. As you can see from the graph, we can see that at some point it starts to be zero, which is when it's free fall, and then landing, it definitely shook up.
our predictions did not match what we found in our graphs and data. We had predicted that the z-axes, or the up and down, would have the highest peaks in the data, while it was actually the y-axes, or the front to back. And I think that was due to the takeoff ramp and the landing both slowed it down way more than we thought it would, even though it's still cleared like an 11-foot gap. But so then some interesting points we found throughout the lab was that the braking and spinning it to the side created very high peaks in the linear and angular acceleration graphs, and also that we ran into quite a bit of issues with the batteries staying charged, keeping the engines and all the other parts of the robot working correctly. And thank you for watching.